Greetings! I received a package from eBay and it looks like this. I've opened it already and inside I've got a mysterious bag of components and no instructions whatsoever, so this is going to be a fun thing to put together. Now it looks quite exciting because as you can see there is something that resembles a high voltage transformer, and I know what it is right now because I looked at my eBay listing. This was ordered quite a long while back, so let's have a closer look. Here is what came in the bag, and literally that's all there is to it. There was no paperwork or no instructions manual. It's just a bag with components, a little barcode on here with some numbers, and we've got a little heatsink, really tiny. It got a little bit bent in the transport, but that's okay, can easily straighten that out with just fingers. It's really thin, so not a biggie. A really cute switch, it's really small. A transistor with Fairchild logo, D880. Okay, we'll have a look at that. We've got a screw, presumably that's that goes into the heatsink. We've got a pin header, 6 pins. We've got a diode for 007, 1 and 4 007, and a resistor. And this is the most interesting part, a transformer, which is a little bit wobbly. That must be a feature. And this part is wobbly too, so it's just sitting loose on the core, and it's been taped a little bit. Yeah, the tape is kind of peeling off over here, but I guess yes, that must have been engineered that way. And there it is on eBay. So this cost me £1.82 with free postage, and it's a DC high voltage generator, inverter, electric igniter, 15 kV, 18650 battery DIY kit. Fantastic description. And yes, it was new, so let's have a look at the listing, what they say over here. And it's got one of those horrible listings that doesn't open properly in the eBay app. But we've got 15 kV transformer, outside dimensions, okay, input current under 1.5 amps, output current less than 400 milliamps. I doubt that's gonna do 400 milliamps. Now, with all those parts in here, it's kind of difficult to work out what's what. I know there's just a few components and I roughly have the idea what to do with it, but a schematic would be nice. Could they not include just a piece of photocopied schematic? Okay. Anyways, I have looked on Google and I found something that looks like this and that closely resembles the components that we've got in here. So we've got the transformer, we've got a transistor here, we've got a switch, but switch is not on the schematic, we've got the resistor, and we've got a diode. So that looks pretty much like our circuit. So let's put it together, and yeah, there is a very good chance I will not get electrocuted, but there is a small chance I will, so that could be exciting. Because there isn't any PCB for this to put it together, and just so we don't have a mess of components just held by the solder points, what I'm going to do is mount this on my favorite material to work with, which is wood, and I've got a random piece of wood. Now, I haven't cut this out purposely for this. It was like that already because I was making a joint, and this is just a spare piece. But yeah, I can put the two high voltage outputs on here and whatnot. So yeah, let's put this together. So I made two little grooves over here and decided to use those sort of block connectors, just singles, and those are going to sit in here like that, and I'm just going to use hot glue to put that in. So let's do one. Just gonna fill up the valley with hot glue and then put this in place, and that should hold it nicely. Hot glue is the best quick way to put things together. That's one. Okay, now the transformer. So that has to go somewhere here, and the question is how to put it. what would be the best arrangement, this way or that way. I think I'll do it like this. Let's just put a blob of hot glue and put that in place. This should hold it now. So those can go into the connectors, we'll do that at the end. And then we've got those 4 connectors, the heatsink and the screw somewhere, presumably. To mount this on the heatsink we'll use the screw, and I'm sure this is a bit of a excess, but I'm going to add some thermal paste just because I have it, so I can make the heat dissipate a little bit better into the heatsink. Okay, after bending the legs like this on the transistor, using the pins on the heatsink, I should be able to just press it into the wood. There we go, and that holds it firmly in place. And now we can attach the rest of the wiring. But before we do, let's put on the switch as well. So we can put it here, like so. That works. So we've got only 2 components, so the resistor and the diode, and we need to wire this up and apply some power. Now I've removed the heatsink for the time being because I realized I forgot to clean off the edges from the enamel on the wire. So there are 2 primary windings on here, so you can see there's 2 wires coming up on one side and the other side. Those are both one sides of both windings, and those are the opposite sides of both windings. So let's I'm going to remove a little bit of the enamel from it with just some sandpaper, which actually makes it really easy. Now I have to establish which windings are a pair. So yeah, so the 2 outside ones are one winding and those are the other winding. Okay, perfect. And before we put the heatsink back in, let's test the actual transistor. Should have done it beforehand actually, but let's just double check what's the pinout on here. And we've got base is first, then collector, then emitter. So base, collector, emitter. And just like in the schematic that I showed you in the beginning, I've made a connection between the end of one of the windings with beginning of the other ones, effectively putting them in series, so it looks more or less like a center tap transformer. According to that schematic, the power, the positive, should go into the connected 2 windings, so the center tap, and one of the taps has to go through a resistor and a diode to the base, and another one should go to the collector. Let's thin the transformer wire first, and I've cut the diode like so. So cathode is on a straight leg, anode is on a bent one, and I'm just going to put a little bit of solder on the transistor legs, and the diode should go cathode, so the stripe on the case should go towards the base, which is the first pin on the transistor from the left. Put a little bit of solder on the anode of the diode and solder the transistor with the bent leg facing upwards. And now we can solder one of the side taps, one of the end taps, it doesn't matter which one, of the transformer to the resistor, like this. And that's one part done. And after bending the other side of the transformer, just so it's almost where it needs to be, I'm going to solder it to the middle pin of the transistor, which is the collector. So let's just get a little bit more fresh solder. I'm going to hold it in place, and that's done. So now we've got 2 connections made. And with a small piece of wire I'm going to connect the center tap to one of the terminals on the switch. Then for connectors of power over here, I'm just going to use two pieces of a thicker, that's like 0.75mm copper wire, pre-make some holes with a nail. Yeah, that's fine. And now I can just bend it off like so and make little loops like this so I can attach crocodile clips with some volts at the end of them. One more small section of wire will allow me to connect the emitter of the transistor to one of the copper terminals that I've just put in, like this. And one more small section of wire I will use, or maybe a resistor leg. Yeah, that's just about long enough. So let's use the cut-off resistor leg. And this is hot and somewhat complete. Just connecting those wires to the terminal blocks like this, and this is now complete. So we've got the output connected to here. The last thing I want to do is put a couple of copper wires in here so we can make our own spark gap that's going to be somewhat adjustable, which will let us experiment with this a little bit. Okay, I've added some markings for positive and negative just so I don't confuse myself if I come back to this. And yeah, I've got it connected to the power supply, set to 3.4 volts, just easy to begin with. And yeah, output on. Okay, and let's switch it on. I can hear it's making a noise, so it's oscillating, but perhaps the gap is a little bit too wide. So let's try to shorten the gap. Oh, look at this. We have a little discharge. Let's see if we can burn through a sticky note. It turns out, yes, we can. It makes tiny microscopic holes. Okay, let's increase the voltage a little bit. Let's go to 4.4 volts, and I forgot to check what amps was it taking, but that's okay. So we've got 4.4 amps, 4 volts, sorry. It's taking 1.2 amps right now. It's actually hitting the limit, so let me switch it off and let me increase the limit, current limit, to maybe 2.2 amps. Okay, that's 2.2 amps. Okay, that's doing quite more drastic. Could easily cut the paper with it. No, let's not set it on fire. But there we go. It's got a pretty little arc. It wants to start a Jacob's ladder over here. Right, let's see. Let's up the voltage a little bit. So yeah, 1.25 amps right now at 4.3. So let's go to 5.3. Okay, let's maybe increase the gap slightly. Okay, it's okay. The happiness was short-lived over here because it stopped working. It's still drawing current about 1.3 amps, and the transistor gets very hot. I've pulled it out and tested it, and the transistor is fine. And if I get the end wires now really close, Not sure if you'll be able to see that, but yeah, there's just tiny sparks can appear, but it's still making, the transformer is making quite a bit of noise, and I suspect the secondary winding is toast, because this is nowhere near capable of pulling out that much current, and I might have accidentally shorted it, so now it's arcing somewhere in between the windings, which is not good. And yeah, you can see the transformer has got all those separations over here. That's basically to allow for more high voltage isolation, so within each section you've got only I don't know, maybe 200 volts or so, and then it's 2, 4, 6, 8, 10, 12 and like that. So there isn't big potential between each winding because it's just basically an enamel wire, but nonetheless something failed very shortly, which is disappointing, but that's okay. I'll look for another transformer to put in here and play a little bit more with it. But for this video I think that's going to be it, so there you go, built a kit, broke it, and end of it. So thanks a lot for watching, I hope you enjoyed it, and subscribe for more random stuff. Share the videos if you wish, give me a like underneath if you enjoyed it, and for the time being, take care.